What is up, everybody? How's it going? So, today I thought would be a pretty good opportunity for me to kind of talk about unit testing in the language. I've been kind of trying to wait, honestly, for a good video to kind of explain this because, to be honest, we've kind of already seen a little bit of how I do unit testing. But I think that this video and the situation that I've just experienced is a perfect example on showing you guys how I figure out how to fix bugs very quickly and very efficiently as I'm building my programming language. So let's just kind of get right into it. So, the bug in question was this. So I was testing, as you guys know, I am actively programming and building this language. You can see here some of these files are blue. That means that I've changed them and I haven't committed the code yet. But I wanted to show you guys a bug that I literally just fixed as of time of recording this video that I think would be, like I said, a perfect example to show you how to do unit testing. So, as you know, we've kind of already gone over this before. You know what this is? This is a reference pointer. And I know before when I kind of showed you guys this, like we had this code here, and I'm showing you guys the code in the GitHub repository because I've already made changes and I don't want to confuse you too much. So we already had code here. We were checking to see if if we found the token of an operator, then we want to process that and want to add the operator overload or the override operator that the class is overriding. So we already had that code, and I guess I wasn't thinking ahead enough to realize that I was only supporting it in one format. So if we look here, the bug that we're experiencing is basically this, right? At the beginning, once you start processing a reference pointer, it's totally fine, right? So if I have something like this, where I have operator not, it's totally fine because the first character or the first set of tokens that we're processing starts with operator. It only becomes an issue when we have a token that isn't an operator. We have a dot and then we have another operator. I also wanted to show you guys this too because I did make changes to the parser, and if you guys are following the tutorial series, this is going to be extremely important for you to add this in. So I'm kind of like showing you how to fix bugs while also showing you an update as well. So if we go down here, we can kind of see, all right, so the flow of this function is going to go as follows. We check the first character. Well, the first character is an A, so it's not going to be operator. So it's going to say, all right, well, let's expect an identifier. That works perfectly fine. Then we check to see if the next token is a dot, and as long as it's not a dot class, right? So if we weren't doing something like a dot class, then it wouldn't have processed it, but that's not the case. So we process the dot, so we say expect the dot, and then expect identifier. Now, if you guys remember, expect identifier cannot be a keyword. So identifiers in our language are words that aren't like keywords that are built into the actual language. So stuff like class, import, module, so on and so forth. So when we reach this operator, well, this is a keyword, right? So it's going to break here at this point. And I didn't realize that at the time. So let's just kind of go through how I decided to figure this out. So what I did was I put a couple of breakpoints. So this is typically the flow that I go through when I'm doing my unit testing. So let's go to the parser here, and I'm going to do a control search. So I'm going to control search and find parse. So I know that the code that we're looking for is inside of here. So we are only really going to be processing this file. So it's going to be pretty easy to track down where this error happened. So let's go back here. So once we're at the top level, we want to put a breakpoint at class. So let's find class here. All right. So we want to put a breakpoint at class so that we know that once we get to this point, we're now processing a class. You don't want to have to like skip over or manually jump over all of these. You just want to jump straight to parsing the class. Now, once we do that, we want to go into class declaration. And we want to put a breakpoint inside of this while loop. So I'm going to start it at module because this is the point at which we start trying to figure out what each thing is basically. So I'm going to start debugging and let's just kind of go through the flow. So here I'm going to also see, can I put this on the side? There's a way that I can, yeah, here we go. All right. So I'm going to split this vertically so you guys can kind of see what's happening real time. So I'm going to go into here and I'm just going to hit the continue. And that's just going to literally jump me from parsing this class declaration to parsing things inside of the class. So the first thing, just to make sure that we're inside of the right class, let's just make sure that we're where we are expected to be. So typically what I'll do is I'll go down here and I'll look in my variables section and I'll go to this, which means the current instance of the parser, and I'll check the tokens. I'll click the tokens variable. And I want to make sure that the file is in fact the file that we're processing. So, okay, it looks like we're processing syntax.sharp, so that's good to go. Also, it would be helpful to look at the current token and see where we are in processing this file, because just because you're processing this file, I don't know, maybe you're somewhere that you're not expecting to be. So if we look, the current token is def, and it's on line 7, column 8. So the column doesn't really matter, it's just a line. So okay, look, we are right here, so we're right where we need to be. So what we can expect to happen is processing this function first, and then immediately processing this next. So here I'm just gonna kind of go through this. All right, so it looks like we're processing this method now. So I'm just gonna step over this because we don't really care about the method. We care about this expression here. We haven't gone over this on how to parse variable declarations. I'll do that in a later video, but I'm just going to kind of go down here and we can kind of see what happens. So assuming that we've already had this code created and I've shown you guys how variables are processed, we're just going to go down here and we're just going to like skip through all the code manually. So I'm going to go here, skip through all the code. Now we get to an important part, right? So this, again, I'll go over this later, but this code basically just tries to figure out what the heck's going on. So it tries to figure out, is it a single colon? If so, we need to process the type of the variable. And then, if there's an equal after that, then we need to process some expression. But in this case, we have this infer token here. So we're just going to immediately process an expression. So that's kind of what it's doing. So as you can see here, we found the infer token, and we're just going to immediately jump the gun and start processing expression. So of course, we haven't gone over expressions either. We'll go over that in a little bit. So now I know what type of expression this is because I've written all the code here. This is what's called a dot notation call expression. And if we go back up to our grammar sheet, you can figure this out pretty easily. So in my expressions, grammar, you can see here, once we call the function parse expression, I have what's called a primary expression. So if we go up here to primary expression, you can see here I have a dot notation call expression as what I am thinking that this is. So let's try to find that. All right, so a dot notation call expression is something that signifies a optional dot, then a utype naked, which is basically just a type identifier without the brackets. Again, we'll go over that a little bit later, but so we have a naked utype, and then we have a value list here, and then we have a dot notation call expression again, and some other stuff. So let's just kind of go through. So I'm going to go through my expression parser here, and I'm just going to skip over this. So it's obviously not a literal, right? That doesn't make any sense. So I'm going to skip over that. Obviously, it failed, so that's why I didn't jump in there. It's also not a dot because it starts with an A. And if we look at our current token, it's checking the next token. So it's peeking forward after this infer symbol and looking at the A. So next, it is in fact a utype. Whoops. So this code is in fact a utype, but it's not exactly what we're looking for. It's a dot notation call expression. So this code here expects there to be a dot class immediately afterwards. And if you guys remember in my parse type identifier function, I had this code where I'm checking to see, or parse reference pointer, I'm checking to see if there's a dot class. So this is kind of why I had that code there. So it's obviously not that, so we're just going to skip over that. It's not a self, it's not a base. All right, so here we finally get to what we are looking for and what I already know that it is. So it's a dot notation call expression. So I'm going to jump into here. Again, verify that your current token is where it's wanting to be or where you're expecting it to be. So we're still processing A. So if we peek forward one character after this, it's not a dot, so we just skip that. Now we're going to parse a utype naked. So all a utype naked is like I said, it's a type identifier without the brackets after it. So we're going to go into here, and then we're in our type identifier, and we've already seen this code before, so we kind of know what to expect. So we know it's not a native type, and we know A is also not a function pointer. So So we can kind of jump over that code. And now we're at the point of where we want to be. So the reason why I went the long way and showing you guys, all right, I'm stepping over this code, I'm stepping over that code, is because you don't want to assume things when you're unit testing your parser. You don't want to assume that certain functions are being called and certain things are happening. You want to make sure that it's going through the flow exactly as you're depicting that it's supposed to. Because you might get to this function in some weird way and it might consume characters that you weren't originally expecting. So just keep that in mind when you're unit testing your parser and you're trying to figure out bugs. Don't assume anything. Like assume the worst and assume that everything's broken. That's typically how I go about doing it. So once we get into here, here's where I change the code. So you can see here the blue line and the green line means stuff that I've either added or changed. So originally, the way that I had it was in my parse reference pointer, I did the check, and this code was working perfectly fine. I did the check to see if it was an operator, and if so, then I parse the override operator as well. Otherwise, if it's not, I parse the expect identifier. So this code is doing the exact same thing. I condensed it to make it a lot cleaner. So obviously our first token is not operator. So we're just going to expect an identifier. And in our previous code, that worked perfectly fine. It only became a problem when you got to this function here. So when you got to this function, or this section of code, you have your while loop and it's checking for a dot and a class, right? So when we get down to here, as you can see, here's the green part, and I also put it to do here to kind of explain that. So originally what we would do is we would just expect a dot and then we'd immediately expect an identifier. That's incorrect because although I am supporting operator being up here, so like if you had something like that, I realized that I wasn't supporting a dot operator or a dot y dot z, whatever, like you get the point. Also, I wasn't even supporting something like std hashtag some variable dot operator, right? Because this some variable can be a class that has an operator overload function that you want to process. So I wasn't even doing that. So there was definitely a big flaw in my parser. So now looking at the new code, what I do is I peek forward one character. If it equals operator, I expect the operator, and then I expect the override operator. Now, this is a new function that I created. So what it does is it basically does what you think it does. So we want to expect an override operator. Previously what I did, and this is why I kind of put it into a function, is because I had this code up here which is kind of messy, and it basically does the same thing. It checks to see if the current token ahead of one character is an override operator. If so, it adds the appropriate data. So instead of adding operator and the override operator, I just add the override operator itself. So I advance one character, I check to see if the current token is equal to one of these tokens, as we've gone over before. Also, another thing I added to the parser is I added support for a not override operator. So just keep that in mind if you guys want to stay up to date with the tutorial series. That's definitely one thing I added. So if we go back to here, then if it's an override operator, we check to see if the AST is not equal to null. It's just a sanity check to make sure we don't crash our compiler. We add the token and then we return true. Otherwise, here's the important part, we want to complain and say expected override operator. So in this instance, even at the top, if we find operator, the user is going to get an error if they don't have a override operator that is supported. So that's very important, and that's kind of why I split it out into this function. It simplifies the code, and I'm kind of reusing it anyway, so I might as well put it into a function. So yeah, that's what happens. Then we return true. Now, in the instance of, like, let's say we had std hashtag some variable, and we had some variable dot operator whatever, then what would happen is we'd process our identifier, we'd skip over this code, we'd process our hashtag, and then we'd process our identifier. So we'd process our some var identifier, and then we'd process, so we'd skip over this code, we'd process a dot because we need to continue the reference pointer. And then we do the same code here. So we just check to see if it's an operator. And now it's very important to note that you have to return true immediately after this, because I mean, it the expectation for this is for it to be a function. So the user's not going to say like dot some other crap behind it, because the expectation is this is solely always going to be a function. So you don't want to continue processing things in here, nor do you want to process stuff like, a generic, whatever. When I add generic functions in the future, maybe that'll be a feature that we add. We can have like a generic operator overload. But for right now, just kind of do it like this. So that's kind of a quick example of how I unit tested this code. It's literally just the same code here. I just copied and pasted it into the appropriate spots. So yeah, that's pretty much a perfect example. Also, I would like to go over the code inside the AST that I use for my unit testing as well. We've kind of seen it before, but whoops, wrong one. We've kind of seen it before, but it's pretty much the code that prints out each AST um, to a string, and it prints it out to the console. So let's see if I can find this here. All right, so here's the code for printing out an AST. So whenever you're unit testing your compiler, this is going to be a huge help. Also, really quick, so sorry I'm bouncing around a little bit, but when you're doing this, please make sure you do not add this operator token. That's very important. The way that I process reference pointers on the compiler level, this is very important, so take note of that. Do not add this operator token to the actual token list here. And you'll see why I do that later. But going back to the actual AST, so when we look at the AST code, that's the code that you guys have been seeing where I process, or I print out all of these helpful visual diagrams of how the AST is laid out. It's pretty simple, I think. So pretty much all I do is I create a get indent function. And what that is that represents how nested we are in the actual code. So considering that this is going to be recursive, indent is always going to be a static function, which is just fine. So when you want to convert an AST to a string, we increment the indent, which means we want to indent one time. And we have to do it at the top of every single time we call toString, because if you have a nested AST, then we want to handle the information accordingly. So what we want to do is we want to get the indent, and all it does is it creates a pipe bar, and then it just puts a tab. So that's kind of how you have this kind of formatting here. It's just a pipe bar, and then however many tabs you need to put for each indent. So every single pipe bar contains a tab in the middle of it, and so on and so forth. So that's how you create this really nice formatting. So once you get the indent, you want to say AST, and you want to put the AST type to string. So you want to pass in the type of your AST here. And this is this lovely function that I showed you guys before. I showed you guys a very quick way on how to create this function if you have a giant enum of different ASTs. So definitely check out that video. I'll post that in the description below if you guys want to figure out how to quickly write a toString function if you have like a giant AST or a giant enum list. So once we have that function created, then we want to format it. So we want to say AST, put this parentheses here, put this other parentheses, and put a new line. So you want to make sure that the user kind of can distinctively see what it's processing. So this AST is a primary expression, this AST is a dot notation E expression, so on and so forth. So once we do that, then you want to immediately put, so you want to get the indent again. So that's what this information is here. So you want to get the indent one more time. You want to put this, and then you can kind of use this to kind of follow this line along. It's just a very easy way to be able to keep track of what's currently inside of the AST that you're looking at. So we put a new line there, we get another indent, and then we want to print out all of our tokens. So in this case, let's find one. All right, so here's an example where we have our token printouts. So we say token, we put our parentheses here, and then we just create a for loop, which goes through all of our tokens. It adds this character, the string start character, and then the string end character, and that just denotes that this is the actual token that we're processing. And then the way how I, do it where I put the commas in the correct position is all I do is I just say if I plus 1 is less than the token's dot size, then put a comma. And what that means is that if there's another token to be processed after this one, put a comma. Otherwise, if we're at the last token, well, if, for instance, your token size is 3 and I is at 2, well, 3 is not less than 3, so that's why this code here works. So that's how I do that. And then, of course, I end my token printout by ending it with the parentheses. You want to make sure you put a new line immediately after that. So once you do that, then you want to print out your abstract syntax trees. So it's going to just recursively call back into this. So you're going to want to say get an indent. So you're going to want to get a indent again, and then you're going to want to print out how many ASTs are found. So this is important because this is a quick way for you to kind of see without having to physically count, because you might have a big AST with a bunch of nested, various nested ASTs below it, and you just don't want to have to count them. So this is just a quick way to do that. You just pass in the size, and you close it with the parentheses. And then of course you just call that subast.toString, and then you just want to create a new line, get another indent, and then you want to end it with this. So like here's an example where here's the ending right here. So I start it, I print out my tokens, and then I print out my ASTs, whatever, and then I just have my list of ASTs, and it's just going to recursively call back into this function, which will recursively increment the indent, which will handle, indenting everything into a nice format. And then, yeah, you just basically add this to the token stream or the string stream here. And then once you do all that, just make sure that you decrement the indent to make sure that, everything works properly so you have the correct formatting. And then you just return the string. So that's kind of the code that I use for printing out ASTs. It's very helpful to kind of figure out what you need to process, or like, I don't know, if there's a bug somewhere, it's pretty quick and easy to track down. And we're definitely going to be using this a lot when we start working on the backend part of our compiler, because once we start getting into the backend, we're not going to remember the formatting of every single AST we created in our language. So we're just going to use toString to figure out, all right, well, what do we need to process, and what are the things that we expect to process when we get to this AST. So yep, that's pretty much it. If you guys have any questions, as usual, definitely put them in the comment section below, and I can hopefully get to it as quickly as possible. So hopefully that helped you guys out a little bit with figuring out how to fix bugs in your parser, or how to narrow down maybe some things you want to improve. So as per usual, I'm going to go up here to my repository. If you guys would love to help out the channel, definitely head over to my GitHub repository at androidevcd/sharp and watch, start, and fork the repository. That's going to give this repository a ton of more visibility and let other developers know that this language exists. And if you guys would love to keep a little bit more up to date with what's going on in the day-to-day with the language, definitely head over to the remastered branch. Master and remastered are pretty much the only ones I use, so just keep that in mind. And this is going to represent the branch that I update very frequently. Sometimes I take little breaks, like this time I took a week off, but typically I'm updating this on almost a day-to-day basis. So if you guys are interested, you can head over to the doc folder, and that's going to contain a few important documents, two of which I update pretty frequently, such as the change list document, which is going to hold all of the various things that I've done to the language in the past. And you can head over to the roadmap file if you're curious about looking at things that I'm looking to add into the future for the language, or maybe stuff that I've already done as well. So that's it for today. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.